David Smith here with one more Flip Classroom math video. 3 tips before we start. First, you can increase or decrease the playback speed if that helps you get through the video. Second, you can pause the video at any time to catch up with your notes. Third, you can turn on the captions to watch my words go by on the bottom of your screen. Today's lesson covers the volumes of geometric solids. Now, if you remember our last lesson, we poked about inside geometric solids, figuring out angles and lengths. Now we're going to incorporate some of that stuff, but now we're going to calculate some volumes. So the first section of figures are prisms, and volumes of prisms follow the same formula each time. But let's first define some prisms. A prism has 2 bases that are parallel and identical. They're congruent. So these 2 bases are rectangles. It's the top and the bottom. And then the sides are rectangles for every single one. So each of the sides or the faces of this object are rectangles. So what we call this is a rectangular prism. Now this next one is called a triangular prism. Now notice the faces are still rectangles, but now the bases are triangles. We have a flat bottom that's a triangle, and we have a top that's a triangle. So this one's called a triangular prism. All right, tell me what that one's called. We call this a cylinder. Now the formula for volume of all 3 of these is the same. We're going to express it a little differently. For these 2, the volume, I'm just going to use V for volume, is the area of the base times the height. And the height would just be this distance here. That would be height, or in this one, this distance there. So that's the height. So if I gave you measurements for either of these that would allow you to calculate the area of the base and the height, you can calculate the volume of these 2 figures. Now the volume of a cylinder is the same idea, area of the base times the height. But a cylinder is a regular geometric figure based on a circle. So what we do is we go volume equals pi r squared h. So pi r squared is the area of the base, and then our height, again, just like the other ones, would be the distance between the 2 bases. All right, let's do a problem. Now this one's going to be a little challenging in that here's the problem. We're talking about geometry, but there's no figure here, right? So you're going to have to at least visualize the figure, or if you do, as I recommend, you're going to actually make a drawing of your figure. So let's get started. Find the volume, okay, good, we're doing volumes, of a triangular prism. Okay, I know it's got triangular bases, rectangular sides, whose base is an isosceles triangle. Now you're going to have to dig into your geometry vocabulary or look it up. What's isosceles? It's a triangle that has 2 equal sides. So whose base is an isosceles triangle, whose equal sides, so it's telling us what they are, measure 12 centimeters, and the angle between the sides is 130 degrees. Now this is important because we're going to need to use that information to find the area of this isosceles triangle. And the height is 15 centimeters. So I'm going to go ahead and sketch that prism. So here is the front and the back. It goes all the way. The height is 15, so we know that. And the 2 sides are 12, like that. And then we know this angle here is 130. Okay, so there's a sketch of my prism. Now I'm going to make one more sketch before we start calculating. I'm going to just draw this triangle so that we can see clearly how we need to find its area. Because here's the pathway. We first need to find the area, then we need to multiply it by the height. We're going to do that in one calculation, but we're going to think about it in 2 steps. So here's that triangle. We got 12-inch sides. This is the top or the base, they're the same. And this angle is 130 degrees. Now, I want you to think for a minute. We have a formula that lets us find the area of this triangle directly. Now we could figure out how to calculate the height of the triangle and the base, and we could do a calculation using the regular area for a triangle formula. but we have one that deals with sine. So think for a minute, what was that formula? Okay, that's the area of a triangle using sine, and if you know two sides and the angle between them, which we do, we can calculate the area of any triangle. So check it out. That's called the area of a formula using sine. I put that here, 1/2 AB sine C. AB are the two sides that you know, and C is the angle that's between them. And we have that. So the area of this guy is going to be 1/2 times 12 times 12 times sine of 130. Okay, so that's the area of the triangle. Now the volume of this is just the area of the base times the height. So that's pretty simple. We can do volume equals 1/2 times 12 times 12 times sine 130 times 15. And that's going to give us the volume in cubic centimeters. So go ahead and pause the video, catch up on your notes if you need to do that, and calculate this volume for me. Okay, here's what I get, 827 cubic centimeters. Okay, here's a more simple, more straightforward calculation for you. Calculate the volume of a cylinder with a base radius of 2 centimeters and a height of 7.5 centimeters. So what I want you to do now is pause the video and draw that picture and label the distances that you know. All right, this is what I get. Your picture should look roughly similar to that, and you want to try drawing them to scale. So this is 2, and that's 7.5. I mean, I know it's not perfect, but it's roughly in the right ballpark. This is like almost 4 times that. So there you have it. Now, I want you to pause the video and calculate the volume of that cylinder. All right, let's see how you did. Here's my formula. Here's my plug-in step. I just put in 2 for my radius, 7.5 for my height per the diagram. Do my calc, and I get 94.2 centimeters cubed. Okay, let's talk about 2 more types of geometric solids. We have a pyramid. And if you think about the pyramids in Egypt, you're right, that's a pyramid. And then the second one is a cone. Now let's talk about how we define these. The pyramid has a polygonal base. It means that the base is a polygon, like a square or a rectangle or a hexagon, and you just name it for the base. So this would be a square pyramid, or maybe that's not quite a square, so we'd call it a rectangular pyramid. If the base was a hexagon, we'd call it a hexagonal pyramid, and so on. The faces are isosceles triangles. So that means that the faces are going to be have equal sides, and that's what makes it into a vertical, like a right pyramid. Okay, so that's a pyramid. A cone is much more simple. The base is a circle, and the face is just this curved surface that wraps around. Now there's one more thing that we talk about with pyramids, is we talk about their heights. So the height goes from the point, with cones, same difference. It goes from the point to the center of the base, and it makes a right angle. Same thing with a pyramid, goes down to the center of the base, and it makes a right angle. Okay, so volume formula is really similar to the prism. Now, what would you think if I made a square prism and looked at that volume and then looked at a square pyramid? All right, so the formulas are going to show that the volume of these are less than their corresponding prisms or the corresponding cylinder to that. So the volume is just going to be 1/3 times the base area Okay, so the volume is just 1/3 base area times the height. Now remember, if this was a prism, it's just base area times height. So we just have that third in there to account for the fact that the volume of that is much, much less. Now pause the video, see if you can come up with the formula for the volume of a cone. Okay, let's see how you did. This one is just 1/3 pi r squared times the height. That's it. One more geometric solid. This one's the simplest of all, spheres. So there's only one number that describes the sphere, and that's the radius. because the surface of the sphere is a set of all points equidistant from one point, which is the center of the sphere. So once you know the radius of a sphere, you know everything there is to know about it. Now here's the volume formula. 4/3 pi r cubed. Simple, simple, simple. If I tell you the volume of a sphere, you should be able to back calculate to get to the radius, or if I tell you the radius, you should be able to get the volume nice and fast. All right, let's calculate the volume of two solids. These are the first ones that we looked at. Here is a rectangular prism. We have a rectangle base. It's not a square prism because the sides aren't quite equal. And we have its height of 7.4. And then we have a cone here with a radius of the base as 3.2 and the height's 11.5. If you're feeling bold, pause the video, do both of those calculations. Let's see what you got. All right, straightforward plug in. The volume formula is 1/3 times the area of the base, which is 4 times 3.5, times the height, which is 7.4. Crunch those numbers, and I get 35.4 centimeters cubed. Remember, when you're dealing with volume, it's a cubic quantity, so your units are always cubed. All right, let's go attack our cone. Now I have to point out that when I first labeled this diagram, I did not do it correctly. I did not consult the notes, or I did, but I didn't quite see what was going on there. So this 11.5 is what we call the slant height. It's the distance from the peak of the cone to a point on the outer edge. So it's not this straight up and down height, which we need to do the volume calculation. So this one's going to require a preliminary calculation so we can find that height, and then we can find the volume of the cone. So pause the video, see if you could write an equation that would allow you to find this height. I'm just going to label it as a little h. All right, if you noticed that you have a nice right triangle right there, and that lets you use the Pythagorean theorem, you're on the right track. So check it out. We know that the hypotenuse is the 11.5. That's the side across from the right angle. So h squared plus 3.2 squared is going to equal 11.5 squared. That's what I've got here. Now I move the 3.2 squared over to the other side of the equation, take the square root of both sides. I have h squared equals the square root of these two things. Pumped it into my calculator for h, I get 11.0, so we can put that right here. Now, pause the video and calculate the volume of this cone. All right, so I just did my plug-in. 1/3 times the area of the base, which is pi r squared, r is 3.2 squared, times the height that we just found. And what I get there is 118 centimeters cubed. Okay, I wanted to come up with a problem that tests your critical thinking a little bit more. So check this one out. A cone has a base radius of 2.5 centimeters and a height of 10 centimeters. Okay, so basic cone, we could sketch that. Let's go ahead and do that. Okay, so here's our cone. Good idea to get used to sketching these figures. Now here's the question. If the height is held constant, in other words, we're not going to change the height, how much must be added to the cone's radius to double its volume? So pause the video and think about that for a minute. What are you going to have to do to answer that question? Okay, here's the overall process. To double the volume, we first need to find out what the current volume is, which is pretty straightforward calculation, so we'll do that. Second step, we need to double that volume and then use the volume in the equation to solve for the new radius. Okay? So first step, and you should be able to do this, no problem at all, calculate the volume. Pause the video and do your best. Okay, let's see how you did. My volume formula for a cone is just 1/3 pi r squared times the height. So I plugged in my numbers, I do my calc, and I get 65.4 centimeters cubed. Pause the video, do the next step. Okay, did you remember what the next step was? We need to double that volume so we can back calculate the new radius. So we're going to multiply that by 2, and that's going to give us 131 centimeters cubed. So that's the new volume that we're then going to use to solve for the new radius. So pause the video and do the plug-in step for that calculation. Okay, here's what I get. 131, that's our doubled volume, is 1/3 pi. Now I've called this R2 because that's our new radius squared times 10. So now we can do that and solve for radius. Now I like to practice my algebra skills, So pause the video and see if you can rearrange this equation so R2 is on one side and everything else is on the other side. Okay, so this is what I get. Notice how R2 is alone. The reason there's a square root is that ultimately we have to take the square root of R2 to figure out what R is. So here's the rest, 3 times 131. The 3 had to come up to get on the other side of the equation, and then the 10 and the pi had to go down to get on the other side of the equation, and then we put the square root over that. So go ahead and pause the video and calculate R2. All right, so this is what I get for R2. How's that? Do you feel good about solving this problem? Have you solved it? Pause the video and read the question again and make sure you think you've solved it. Good, I'm glad you realized how much must be added to the cone's radius. That's the new radius. It's not how much must be added. We're going from 2.5 to 3.54. So the answer would be 1.04 centimeters. And this is just the kind of thing that the IB is going to be a little tricky with. They're going to test your ability to reevaluate your work. Look back at the question. Make sure you've answered what they want. Now, this problem has a mild to moderate level of extra complexity and critical thinking. Don't underestimate some of the more tough problems in the exercises. But just know that with all the formulas you have and with the formulas for area and things like that in the IB formula booklet, you do have what it takes. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. Remember, you can also come back to this video again and watch it for deeper understanding. If you liked or enjoyed the video, please click like or subscribe down below.